The International Space Station has been a working science laboratory and exploration outpost for more than 15 years and fostered advances in science and technology in that time. But it's the possibilities for future discoveries that have the crew members excited about this mission.
Potential is huge, of course, for space station. The idea on it is about discovery. We don't really know what we're going to learn, but we know we have the potential to learn many, many different things, and it's almost with basic science.
A real opportunity to do something useful, something helpful for humankind, so that humankind in the future would live better, longer, happier, that they develop, that it will be more comfortable.
And not just here on Earth. Deep space exploration missions of the future will take years to complete, but the human body starts reacting to the space environment in far less time. And it's not just the loss of bone strength and muscle mass.
There are changes detected in the internal organs. Skin reacts differently, blood reacts differently.
So this crew will take part in a number of experiments as test subjects, gathering data to quantify those physical changes while searching for their causes. They will also each have daily exercise that is proven to keep crew members strong and fit while countering some of the negative effects of zero-G.
It gives us a unique possibility of actually doing research on how this condition in the bone develops and how we can think of countermeasures, how we can treat it, what medication works and what does not work.
Another study I signed up for is called the Sprint Physical Training, and what that's trying to do is determine, is it the amount of exercise that you do, or is it the intensity of the exercise? And so for Sprint, every one of my workouts will go to max intensity.
To see if one or the other is more valuable. Some research focuses on the psychological effects of long-term isolation on the individual as well as on the group.
The better they work together, the better the team they are, the more results and the more adventures we gain from that flight. It is the psychological environment in the crew is a very important component of a successful flight.
The effects of being in space aren't just felt by the human bodies that are there. Station science is investigating other impacts that must be dealt with to support future exploration.
Not only does the body change itself, the actual cell itself of an organism will change when it senses zero gravity or microgravity. But they don't know why it's changing or really kind of how it's all working. So we're doing experiments using these plant cells and structures and finding out how they change and why they change.
On this mission, the station also hosts dozens of experiments in physical sciences, learning how fluids and materials and equipment cope with higher radiation and lower gravity than they encounter on Earth. And there are investigations into new technologies that will improve the chances of successful flights in the future.
If we are going to send humans to Mars, you'll never know what will break. And if we have a 3D printer where we could just, boom, print out a part, throw it in the machine, fix whatever's broken, this really opens up a whole new dimension of long-range space travel. So we will have the first capability for 3D printing on our expedition.
A scientist that I recently met actually told me that they just recently implanted a trachea to a person that they generated from stem cells that came out of space research. So some of these benefits you might not even actually hear about ever if you don't have one of these illnesses. But if you do, then you're in the position to get a much better treatment than you would have without space research.
There's a lot of spacewalking in the plan. From the Russian segment, EVAs are being prepared for June, August, and October to refresh external science experiments. And there are 3 U.S. spacewalks in the plan for the summer to begin configuring the station for its extended mission on orbit.
You'll see in Expedition 40 and 41, we're just going to start to lay the groundwork for extension of the space station. So we'll be doing a little bit of management both inside and outside, getting things moved around and prepared for this further exploration into the 2020s.
Over the next 6 months, most of the cargo ships that supply the station with food, fuel, clothing, and scientific supplies will make a call. the Russian Progress freighter, American commercial ships Dragon and Cygnus, and in August, the fifth of the European Space Agency's automated transfer vehicles, which will be the final ATV to fly. ATV has been a big success, and not just for the tons of supplies it has delivered to orbit. ATV gave the European space industry a chance to develop new technologies that are already being applied to the future.
The technologies that we use for ATV are actually being used for the future vehicles. So the service module of the MPCV Orion module that NASA builds will be actually an ESA development that is based on the ATV technology.
Expedition 40 ends when Swanson and his Russian crewmates head for home in early September. Sarayev becomes commander for Expedition 41, which will greet 3 new crew members near the end of the month. NASA astronaut Butch Wilmore, veteran cosmonaut Alexander Samokutyaev, and first-time flyer Elena Serova, who will be the first female cosmonaut to serve as an International Space Station crew member. That group will press ahead with the ongoing mission of the international partners.
Really just looking at getting the space station into its best possible configuration for extension into 2024, and really starting to lay some of the groundwork for bringing up commercial crew vehicles to the American segment here in the next few years.
To help support this mission and prepare for the long-range missions of tomorrow.